everyone, today we are going to look at a famous math pattern 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus and so on all the way to infinity, and surprisingly it adds up to exactly 2. In my very first video, I showed you how adding up all the normal numbers 1 plus 2 plus 3 and so on up to infinity gives you a strange negative fraction minus 1 by 12. So in this video, I want to show you how adding an endless list of fractions can give you a clean simple whole numbers. Let's get started. If I ask you to keep adding numbers together forever, your brain tells you the answer should keep getting bigger and bigger. In fact, if you told a computer to literally add these numbers one by one forever, the machine would run out of memory and crash. But in advanced math, we don't actually try to add things forever. Instead, we look at the hidden pattern of the series. Let me show you what I mean using two cakes. Imagine you have exactly two whole cakes on a table. So you eat the first cake completely. Now you have one cake left. Instead of eating it all at once, you cut it exactly in half and eat 1 by 2 of it. Next, you take the remaining piece, cut it in half again and eat 1 by 4. You cut the next piece in half and eat 1 by 8, then 1 by 16, and you keep doing this forever. Physically, you are doing a never-ending task. You are writing down an endless list of fractions, but logically, are you ever going to eat more than those two cakes? Absolutely not. No matter how many times you chop it up, you are just turning the second cake into tiny crumbs. The pattern will never pass the number 2. Now, let's get started and prove this series. Let's say our entire infinite sum is equal to the letter S. Therefore, S equals 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 and so on, keeping go forever. Next, let's multiply both sides of this equation by 1 by 2, which gives us 1 by 2 times of S is equal to 1 by 2 times of our entire infinite series inside the bracket. So, to simplify it, we just distribute that 1 by 2 to every single number. The first term becomes 1 by 2, the second term becomes 1 by 4, plus 1 by 8, plus 1 by 16, plus 1 by 32, and so on to infinity. Now let's subtract this new series from our original series S. Our original S is positive and our half of S is completely subtracted. When we line them up, every single fraction pairs up with its negative match and cancels out perfectly. The halves cancels, the quarters cancels, the eighths cancels. So we are left only with the very first term 1. So S minus half of S equals 1. To solve this, S minus half of S just leaves us with half times S. So half times S equal to 1. Finally, to make S our subject, we multiply both sides by 2. Therefore, we will get S equals 2. Now, back substitute this value of S. 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus and so on up to infinity equal to 2. Hence, the series is proved. Just like our cake pieces predicted, infinity behaves beautifully and the endless sums equals exactly 2. Thanks for watching and I'll see you in the next video.